What we want to look at now is something called slope-intercept form, or the slope-intercept form of a line. And the generic form speaks of it in a way where y equals mx plus b, where m represents our slope and b represents its starting point. So let me look at an example with you. Y equals 2x minus 4. Now based on that, can I determine what its slope is? Well, since it fits this form, y equals mx plus b, and actually let me rewrite it so you can see it specifically, 2x plus a negative 4. So therefore it lines up exactly, so the pluses are in the same places. So I have y equals 2x plus a negative 4, where its slope is 2, and its starting point in b, I don't know why they call it b, it's just, terminology that's been brought along. And the starting point is negative 4, the place where it crosses the y-axis. Once we have those two pieces of information, we can graph a line. I want to go to its starting point, which is negative 4. And then from that point, to find the next point, I'm going to use its slope. The slope is 2. And in fact, it's 2 over 1, rise over a run. So it tells me for every one spot I go over to the right, I can go up 2 spots. And that's where a next point on the line will be at. Then likewise, from this point, I can go over 1 and up 2. And that's going to determine another point on the line. So once I have the starting point and another point determined by its slope, its rise over run, I have enough information to graph that line. And that's one of the beauties of the slope-intercept form of a line. Let's look at another example. Y equals 1/2 x plus 2. First of all, I recognize that it's in slope-intercept form. So all I have to do is look at the m coefficient and the starting point coefficient. Well, the starting point is at 2, a positive 2. 1, 2. Its slope, it's not a 1/2 slope, or like a fraction 1/2, and as much as it is a direction. Over 2, up 1, rise over run. So I'm going to go over 2 spots and up 1. And that's going to determine where the next line, or the next point is at. And those 2 points, if I drew my line straight, what would determine? There's the equation of the line, or the graphical representation of the line, its picture. This is 1/2 x plus 2. My last example here, I want to graph the line 5x plus y equals 4. Well, I notice that it's not in slope-intercept form, but that shouldn't be too difficult. We can rearrange it so that it looks like it's in slope-intercept form, which is basically y equals. So to get this to be y equals, it looks like I need to subtract 5x from both sides. And now I have it in slope-intercept form. And now I can graph it from its slope-intercept form. Starting point at plus 4. And there, negative 5. Well, what this negative 5 means, and it's over and understood 1, I can think of it in 2 ways. And let me show you both ways. First of all, negative 5 over 1, it tells me my run is over 1. And then my slope, or my rise, is down 5, or a negative 5. 1, 2, 3, 4, 5. So that's where the next point is at, and these 2 points will determine a line. Other way that I can look at this slope is as a 5 over a negative 1. Both of these equations right here represent negative 5. So what does this slope look like then? Well, this one tells me I go backwards 1 and up 5. And there's the other point. You can see then, all I did is I just traced the line the other direction than the way I did before. And so there's the equation of the line. Although it did run through my equation, sorry about that. But there's the graph of that line. Using using y equals mx plus b form, or what we call slope-intercept form.